Today, we're going to do a hands-on lab of this financial services demo. And this demo this demo is right here, and how to build it is over here on this YouTube playlist with a lot of step-by-step, and the GitHub, it's open sourced. And then for the actual hands-on lab, there's two admin scripts. This is just the reset. If you're running it for the first time, you could also just run script 10. And then once the administration is set up, then we'll run on the user side. Okay, so at a high level overview of what we're going to do, this is a 2.6 billion row demo in 2 seconds with small computing power. And basically what we're going to do is use Snowflake zero copy clone at the database level and make up to, as you can see here, up to 14, but actually up to 30 clone databases of a 2.6 billion row database. We're going to create these synthetic login names, and then we're going to return the password after we run the admin script. And these are just random names that we're assigned to. If you're using this to like onboard users or to give them a hands-on lab with Snowflake, then you can assign people on their own. All of these assets will be put in here. I'll upload the Excel over here very soon with this content right here. So at a high level agenda, as you can see, up to 30 users. Naturally, Snowflake can pretty much scale for unlimited, in the sense that it can continue to get more users and multi-cluster warehouses, but we're just going to use 30 users right here for more retention, and it'll take about 90 minutes. Okay, and then from an admin's perspective, how the lab is reset to build, we'll run through these various scripts. And then here at a high level is where the user will explore Snowsite, navigation keyboard shortcuts, data manipulation language on a 2.6 billion row table with window functions across database joins, DevOps, so zero copy clone and time travel. You actually see some of that at the database and schema level, and also at the table level. Ultra table swap with, creating a wide table with 120 columns. People have asked, like, hey, can you do that? Yep. And it's switching instantly to a more powerful computing power warehouse. And we're going to do updates to a wide table. We're adding a cluster key and enabling auto clustering. The query profile will kind of performance tuning what to look for. And then we're seeing the 3 types of caches: 24-hour global cache, metadata cache, and a virtual warehouse cache in Snowflake. Finally, transactions, rollbacks, and commits. All right, so this is what this is out of scope. It is in that YouTube playlist, how to build it, or in this open source right here. But what we're gonna do is essentially build this demo. So when we're done, we're gonna run through this script, which is script user 10. So you could just kind of like what the users can do is come here, they could copy the contents right here, and then they would open a new sheet, right? I'll do it over here as an example. I like to name my sheets hands-on last Finter user 10. So since I already have it set up, but if you were to do it here, you would just hit the plus sign, hit SQL worksheet, and then you could paste the contents of that GitHub and then name it whatever you want. Hands-on lab, user 10 or whatever you call it. Okay. All right. So we don't use that because we already have that one here. All right. So I've already built it before, so it's kind of an item pulling script. I'm going to select everything. I happen to have a Mac. Command A will select everything, and I will run this. So you see it's using this database, using the account admin row, dropping various rows, right? So it's dropping these databases if they exist, which I don't see right here. So we should be good, but it's good for you to see that after you build this demo, you can basically reset your account to not have this demo at all, or in case you're making changes to it. And then these are the synthetic users that we're going to create: user 1, user 2, so on and so forth. One good thing as that's running, I often like to go, especially in a lab, I like to go at the activity and then query history and see what's going on. Let me remove that filter. So I like to see what other users are doing. As you see, it's running all these various scripts. Let's come back to our, and now it's dropping the roles, right? So we kind of map one-to-one for a role to a user, and then we assign those permissions to that role. It's a security role using the Snowflake's role-based access control. That's almost done, and then we'll be able to run the next script, which is the admin 10 script. Okay, so what have we done? We have basically reset the demo, so the databases, roles, and users for all of our 30 synthetic users are not in the demo account anymore. As you can see, that FS just happens to stand for FinServ, but it could just be any type of big data. It just happens to be a financial services use case. Okay, so now we're going to kind of hit Command A. If you want to know what the keyboard shortcuts are, you can always click this arrow right here and then click Show Shortcuts, and happen to be on a Mac, so Command A is select all the usual keyboard shortcuts. So now that I hit Command A, I'm going to hit the run here. And so what is this doing? This is now creating, we're going to create two computing power and junior, right? So as you can see, the power is size large compute and the small is smaller. And it's going to create a random 3-letter password. Obviously be careful of doing this in a production account, because it's just going to create synthetic users and passwords. So you generally want to do this in a test account. And the good thing is, when you see in the script, we actually restrict the permissions to a lot fewer permissions, so that each of these users only have access to their database. Okay, so what is this doing now? It just ran the clone statement right here. So these are the 0 copy clones of the database. So it actually created, let's see if we can see it now. It actually created 3 clones. So there you go. So what we're doing is we're considering this FinServ AM database like the production database, right? It has 2.6 billion rows, right? You see the 2.6 billion rows right there. And then so what we did is we made clones of that database. And this is a very one of the favorite techniques of folks in Snowflake, because they're using this for DevOps, right? As you can see, it looks exactly like your production database, quote unquote production database here. And we're just gonna give everybody their own so they could do whatever they want in it. And again, when you create these, it just creates pointers, so it doesn't cost you any additional storage. You can see here we're granting. So what we do is we create the roles, the users, granting the role to the user, and then granting privileges on the schemas and all that very granular permission. We can always see what the password is. And we do set it to reset full if you want to not reset full. So sometimes if you're, so this reset full is kind of like a script to say, hey, I do want to reset all 30 users. Now, sometimes if you're just doing development, you don't need to do that for all 30 users, right? So then you would just set that to 0, and then it will skip all of this using that flag. Okay, so again, notice what's going on here. We're using the junior, so we don't even need to use the powerful one, just using a small compute power right here. It's creating the roles, creating the users, assigning the default namespace and default warehouse and default row, and that makes it really easier for your users to start connecting to Snowflake. As you can see, you could grant the row to the various users, and granting all the privileges. So this essentially is a lot of scripts to just basically say for each one, it's gonna, from user 1 to 30, actually from here it's user 4 all the way up to 30, it's going to be doing the same thing. And then at the end, it's going to show the password. Okay, let's kind of refresh this over here. So again, if you're the administrator of this lab, it's often good to check back over here to see what's going on. As you can see, it's up to script number 6 right now. If we enable auto refresh, we should see that coming in. So as you see, it's up to 22 right now. All right, so that should be complete. Yep, perfect. So everything is, oops, not that script, it's this admin 10, perfect. That is actually the password, DZV, lowercase dz, uppercase V, right? And that was randomly created. So when you're the admin, what you're going to do is you want to make it kind of simple for users. You can see I am just kind of pasting it there and copy it down. And so what I'm going to simulate user 14. Obviously, you're going to, user 1 is here's Iron Man is going to log in, and they're going to basically, you put your account, like here, this happens to be my account, and it'll go in here. But what you want to do is you want to put in your account here. They're going to log in, let's say user 2 is going to log in with the same password, and then here's a link to that handy script on script 10. So they're going to click here and then create the same worksheet. Okay. So this database in this row, I guess we don't really need. Maybe I should update that at some point. Okay, great. So I'm going to simulate being user 14. I could simulate any user, right? But I'll just simulate being user 14. We don't actually log in with this in column C. It's more the green is what we're logging in. So I'm going to simulate logging in with FSHOL user 14. Okay, so let me do that. Let's try something new. Let's see if this works, where we will log in under incognito mode. Yeah, let's try that. Let's try to log in incognito mode. All right, so we are user 14 and we are using this password. And hopefully this works, because what we're going to do is I'm going to be user 14. As you can see, when you haven't logged into Snowflake before, you might get, we're actually going to be using the Snowsite UI. It should go there directly. But let's see. So now let's try this again. User 14. Oops. That's the password in our case. And we are user 14. All right. So that was the classic UI. We're just going to do everything in Snowsite. Okay. So remember, so now we're going to simulate being user 14, right? So what I want to do is I want to hit this, I happen to be in worksheets. Obviously, I can navigate around. I'm simulating being user 14 now. I'm going to hit this plus sign and do a SQL worksheet. All right, and then so I'm going to go back to the GitHub link, which is right here, and I want to copy and paste that into my worksheet. So I'm going to hit this kind of like copy raw contents icon, come back to here and paste it. Now, as you can see, it's all here. What do we want to call it? We actually will call it the same as this, finserv HOL user 10. Script 10, kind of like in the basic syntax. All right. So now let's see what's going on. If we click on the databases over here, now what do we see as user 14? We see very limited permissions compared to the account admin. Let's go back over here. If you see, as you can see in account admin, they have a lot. This is the row-based access control, right? So account admin is the most powerful row. They can see what the account admin has been authorized to see. As you can see, a lot more databases. Now, if we come back to here, this user, user 14 has only been authorized 2 rows. This row 14 and the public row, right? So now let's run it, right? So we're gonna run stuff, and we have very powerful. We're very powerful against here. Let's see the tray table. Oh, and here's the UAT. This is also a 0 copy clone of the production database. We happen to call it UAT. You see lots of examples of the 2.6 billion row table. Okay, so what I want to do is I want to change all of these names where it says HOL 14, which is I'm sorry, HOL 3, which is where it's defaulting to on the GitHub script. I want to change it to 14 because we don't have access to database 3 and we're user 14. So the following instructions, I happen to be on a Mac. I'm going to use Command Shift H, and I'm going to replace all occurrences of fs_HOL3 with fs_HOL and the user ID you assign. So mine is I'm going to find and replace, and you could use the find and replace tool of your choice if you don't want to use Snowflake. So I'm going to hit Command Shift H and watch what happens. See, as you can see, it's going to replace this. I'm going to replace HOL3 with HOL14. Now it's better to replace this because there's actually going to be, as you can see here, there's numerous places where we call this FOS HOL3, right, or 14. So I'm just going to hit yes, replace all, and ta-da! Now, you know, basically all of the occurrences. Now I will only be querying my database. All right, so let's simulate what this is like. As you can see, one of the good things about Snowflake is the computing power was set to auto shut off at 2 minutes. So now we're running it from code and it's going to automatically resume to use this junior row. So let's junior computing power. As you can see, it's waking up the computing power, and basically I could see the ANSI standard, table, right? Object types, object names, columns, views, so on and so forth. All right, and now that started my computing power, which is again small. Let's see if I can resize. So if you click over here, this is kind of just more out of curiosity if you're interested. But I should not be able to resize because I didn't intentionally grant that permission to somebody. But in Snowflake, you can resize, right? So, I cannot resize up. I could switch to a more powerful one here, and we're going to do that later on. But for now, we're just going to start running queries using our small computer. And you see, that took only 3 seconds to not just wake up the computing power, but return our results. Okay. All right. So let's run some business-facing queries. What is my position and P&L as of a date? Right. So here for January 2nd, right, time series data symbol, Amazon trader Charles, right, trading this ticker symbol. They were, they spent cash, so that's why it's a negative. And as you can see, they were accumulating shares as a result. And the closing price on January 2nd was 1,539. So we multiply the number of shares times the closing price to get the market value. And so the P&L on day 1 is 0. And then as you can see, as we keep on buying or selling or holding shares, the P&L will fluctuate, right? So this is kind of like real-time P&L, profit and loss, right? So let's look at that. We can look at the DDL, and it's going to look at this position view, right? So this is not a materialized view in any way. It is using a regular view, and you've got some common table expressions, sum over partition by, basic unbounded proceeding, some inner joins, right? The trade is essentially the fact table with the 2.6 billion rows, inner join to this dimension object table named stock history, and then calculating the market value and the P&L. So we're using these get DDL functions to get the data definition language. Okay, so now let's run the next one and see one of our 3 caches. If we run, actually, I should change this at some point to use this one because I want to have everybody query their own. It shouldn't matter, but we're going to see the metadata cache in a second, right? So whenever you run a count star from an object and you haven't, it will hit the metadata cache. Okay, so notice that was pretty much instantly 39 milliseconds. So we're going to show the first guy. You see 2.6 billion rows. Now this is faster and significantly faster than a lot of old TP systems that I've came from, where we had to actually query all 2.6 billion rows. Let's kind of go back here. Now what I want you to do is hit this query details ellipsis, and you can hit view query profile. And so from there, what you're going to see is metadata based result. So that is, one of the caches inside Snowflake. There's three. Let's see. We're going to see the other caches soon. Okay. So now, see the ranked P&L for a random trader. Okay. So we just grabbed a random trader, and now for Trader Fritz, this is their P&L, ordered by P&L descending. Pretty good, 505 million, and that was TPL, BOD, and then Tesla, so on and so forth. Let's grab another one. All right, so this is just showing you how you can set a variable. And again, this is all on small computing power, and even if we had all 30 people using this small computing power, Snowflake will still be very efficient and can scale out. So you see for Trader Kali, this was their P&L, so on and so forth. And here's the actual trade level granularity. As you can see here, the closing price this is the action, right? So what we did here is there's a buying, they were buying 650 shares, spent $1 million. And then so that was during the month of January in 2019. As you can see, they transitioned to holding every day during the month of February, and then in the month of March they started selling, right? But not as much, right? Which is kind of wise because they did very well. But we just wanted to show you that in order to understand, that the window functions were calculating the profit and loss. Okay, so let's get the ANSI SQL right here. So let's actually see that trade table that we just queried, right? The 2.6 billion rows. As you see, it's just regular ANSI SQL. It's, we have three table types. Actually, we have a couple of table types, but transient is one of them, which is good for like staging tables. And since this isn't a production database, you can read the documentation on what it is, but it's a table that we named trade, clustered by trader, symbol, and date, right? And so this is helpful for clustering. Is basically when you load it and you order it and you add a cluster key, this is going to be very fast to query. So whenever we query this table, we could see the documentation. Oh, okay, I'm going to very likely want to add a filter on trader, symbol, and date, which is what we do here, which is why we're able to query so quickly. All right, so cross database joins. As you can see, here's this FSHOL 14. Now notice this one, you see where it says source over there, it says local. Now we're actually querying from a share, right? So Snowflake's data collaboration is really powerful. This is another database that is mounted as a share called XEPL US Stocks Daily. And as you see, when I float over here, it's a share. So this is, it costs me zero amount of storage, and they could be sharing petabytes of data, and I would be paying zero additional storage every time they update it. I would, get the real-time data. Okay. And so let's go into another more. A share is a pointer to another Snowflake account. So here you can see, querying for Starbucks. If we wanted to run the show database, we could see that it is a read-only share. So a lot of our customers have between first-party data, second-party data, and third-party data, just having that share makes it so much easier in terms of getting rid of the legacy way of transferring files over FTP or API or some such other means. As you can see, it's actually origin. It's almost like another email address, right? Like everyone who has a Snowflake account has their own address. So this is the account where that data is shared from into my account. And shares are read-only pointers. So we can uncomment this command and watch it fail. So let's actually see that. Let's say I wanted to uncomment that and run this. It should fail because, its shares are read-only. Now, obviously, if I wanted to do data collaboration and share back to XEPL or any other party, I could then take their data, enrich it, and then send it back in my own share. But that's out of scope for today. All right, so quick recap. What have we done? We have built, let's go back over here. Let's go to the query history. So I'm back in the administrator view, doing a recap now. And if I hit refresh, we're going to get to see, we should see, there you go, FSHOL user 14. we get to see what other users are doing during our lab, which is great because we don't have to ask people, hey, how's it coming along? We can actually see the query history as they're doing it. All right, so coming back here, so quick recap what we've done. We saw the information schema, the position view with the window functions, the trade level granularity, cross database joins, so on and so forth. Okay, so we're going to do some, actually one thing I mentioned that we were going to do, but I haven't done yet, is wanted to look at query plan. So let's look at the query plan for this view right here. Oh, maybe we'll see. I'm just going to come back over here, and if we view the query profile, let's see why that took so fast. Now notice what just happened. I ran this query again. So now I'm going to show you the second cache. It's actually, I actually usually refer to this as the first cache. It's a 24-hour global cache. Why did it only take 118 milliseconds, even though it's querying a view that has 2.6 billion rows underlying it in the trade table, right? The reason it's so fast is Snowflake has a essentially unlimited 24-hour global cache. So you see query result reuse. It basically knows that the underlying what we call micropartitions, where the data is, hasn't changed, and it's a deterministic query. It's not using a non-deterministic function like current date or current account, so on and so forth. So this is the second cache, right? Query result reuse. And remember, the first one that we saw was the metadata cache. Whenever you say run account start, you're going to see the metadata cache reuse. And actually, what's kind of cool is if you run the metadata cache query twice, it only hits the metadata cache the first time, but then the 24-hour global cache will be maybe possibly faster, but then you see this query result reuse more often. And it's for the, so we'll see it here. If I run, remember I ran this one and I saw metadata cache. If I run this again, it should say the it would say something similar to this query result reuse. Let's run that now. Yep, there you go, query result reuse. Okay, great. So, all right. Okay, so quick, we just finished our recap. Let's start doing some zero copy clone, some DevOps type stuff. Okay, so as you can see, this is UAT right here, right? It's, everybody has access to this trade table, and we want to change our dev clone, right? So everybody's going to make their own changes in their own database. So as you can see, it looks exactly the same, right? I've got the 936 rows in my dev, and then in the UAT, it also has the same 936 rows. So simulating DevOps. Now, we can delete and then record that query ID. So let's say I want to delete all the records for Charles for symbol Amazon. So I'm going to delete those 936 rows. All right, and you can see it took 4 seconds. And I'm going to record the query ID. We could always grab the query ID, using the query history, right? So even in time in the past, but it's kind of faster if I just record it right here as a variable. So now I have a variable right here, and I could select it just by adding a $sign in front of that. And I could see the actual query ID that this delete occurred in. Now, I can verify the records I got. This should return nothing. Okay. And now what's cool is I want to use time travel to see before that query ID. So now when I run this using time travel using the before clause, it should return those 936 rows again. See, as you can see, and that's up to 90 days on the table level. And we also have it on the database and schema level on Snowflake as well, which is really powerful. Okay, so if we were to undo our delete, right? So what's going on here? This is the same time travel right here, but we want to reinsert it back in, which is essentially undoing delete. And that makes DevOps really powerful and lower risk, right? Because if you're making changes in production, especially your production fact tables or something that's really kind of high priority, you want to put some time travel on it. So here we're going to simulate that. and we're going to insert those, 936 records right back in, right? So you see the inserted back in. So we verify, actually this should be UAT. So as you can see, the row counts are the same. All right, so what did we just do here? We showed that our cloned object is the same as our UAT object. Then we deleted the, in our dev environment. And that could simulate what you're going to do when you're making changes, right? And then when you push to production. Okay, and we verified the same as before. Now, we're going to do a clone now. So what I want to do is I want to take this trade table, right? As you can see, for each of us, we all have this 2.6 billion row trade table. I want to trade a clone, and I can name it whatever I want, but I'm just going to call it trade_clone. So remember, there's 2.6 billion rows here, right? So let's see how long that takes on. Oh, that took 1.6 seconds. So if I refresh this here, as you can see, it just kind of created pointers in 1.6 seconds that basically is kind of like a virtual copy of this original trade table. All right, and if we wanted to query that clone object, there you go. It looks exactly and performs exactly like the original source of the clone, right? And we can test updates against our clone, right? We can update, let's say I wanted to set the number of shares and the cache, times 10 times more. So let's do that. All right, so I updated 936 rows. And if I wanted to record the update query ID, and we could see what happened before that update query. As you can see, we have, I think we updated number of shares and a cache, right? Now, I also want to do deletes, and then we're going to kind of look at them together. If I wanted to do deleting records, let's delete against our clone, right? So I want to delete, what am I doing? I want to, for Trader Charles, he's got 936 Tesla trades. I want to delete his records for Tesla. Like, let's say it was wrong. And then I want to grab the query ID for that delete. And we can use time travel to see that, before the delete, it's still there. So remember I said we were going to do swap with? Now this is really handy for multiple use cases. Here we're just going to basically take the trade table and swap with the trade clone. Again, this is common in DevOps as well, where you basically just flip the two objects. So you can see we flipped it. So now trade is called trade clone is now called trade, and vice versa. And we can alter the old trade table to trade previous, which is what we're doing here. So now what do we do? Tesla, now remember, we deleted the Tesla rows from the trade table, and then we swapped that table, simulating a DevOps process. And now the Tesla records are gone, right, from here, because we deleted the underlying trade table. So that's showing you real-time P&L. All right, and remember, Amazon, we multiplied times 10 for the number of shares and the cache now. That has been updated as well. So what did we just do? Quick recap. We did some updates against Amazon, against the trade clone object. Then we did some deletes against Tesla, again on the trade clone object. Then we swapped both objects. All right. Okay, so bear with me. We're going strong. Okay, uncomment this section to test Undrop Table. So one of the things we could do, we'll just uncomment that. We can drop a table. Okay, so here is, let me refresh this. Here is the trade table. Remember, we've made the updates here, and here's the trade previous. Now we can drop a table. And if we hit refresh, that trade table is gone, right? Because we dropped it. And this will fail now as a result, right? Because that trade table doesn't exist. Now, normally, if this happened in production in any other database, you would be very worried. You'd be calling DBAs and, sub 1 alert, possibly 2 a.m. wake ups. But in Snowflake, it's pretty straightforward. All you can do, if you're authorized or whoever is authorized, undrop that table. And that goes up to 90 days of time travel as well. So basically, if you set up to 90 days of time travel, this trade table will come right back. And so now this query will work. So I can select count star, right? So there's my 2.6 billion rows are back again. Okay. Now, one of the things that people ask about is like, hey, how does Snowflake work on a wide table? All right, so let's do that. We're going to create a schema if it doesn't exist called in TPCDS transaction processing for the data. I forget, but we can you can Google it. So there we go. We just created this schema right here, and we're gonna query the Snowflake sample data. All right, let's just go to this link because quick info on the TPCDS. It's the Transaction Processing Council, benchmark. And in Snowflake, in the classic UI, you can hit this plus sign and you can see the various queries. So it has 100 terabytes of data shared to all Snowflake accounts, which is wonderful for us because we get the queries and we get the data. And so we're going to use that data to create a very wide table. So I just queried like the stores. So let's go over. Let me show you over here. If you want to see, I mounted that share as Snowflake sample data. Hopefully you do the same. And as you can see, the TPCDS 10 terabyte data set is here. The store sales object is here. And what we can do is just, do like some quick queries against it just to see what it's all about. So you see there's 29 billion rows over here, some items, some stores. And the reason I'm doing this is basically we're going to do a CTAS statement, create table as statements against all of, I think there's 5 or 6 objects here. And then it will create a new table. So now that whenever we're creating objects, the small computing power would, if you look at Snowflake compute, I think it's called virtual warehouses. You basically look it up in terms of like how much computing power there is. So there we go, virtual warehouses. So we've been using small computing power this whole time, right? But what we want to do is we're going to switch over to a large computing power. So we're burning more credits per hour, but because it's per second billing after the first minute, it optimizes for our most expensive resource. So pretty much 99% of everyone's most expensive resource is human being time. So you don't have to wait. Excuse me. So it's kind of a nice thing. So I'm actually going to switch over to this power one. I could switch over right here. Actually, I'll switch over here. You see, I just switched over to the powerful one. Now we're using the large, and as you can see, that basically reassigned instantly. Or I could do it over here. I could use that warehouse power. Now I'm going to drop a table if it exists, which is this kind of like denormalized table. And then I am going to create this transit table. And you're in luck because I actually ran it previously with various computing sizes. As you see, a medium took 2 minutes and 19 seconds, and a large took a minute 41. And as you can see, what's going on is this junior one's going to auto suspend on its own within 2 minutes of no one using it. But I'm going to use the powerful one, so it is a large, right? So what is this doing? It's going to create in about 1 minute and 41 seconds, all of these objects right here. And then after we're done building that, I'm going to switch back down to our junior computing power, because when we're just running kind of like select or not as compute intensive, we don't need that much computing power. So that's a pattern that you'll see a lot in Snowflake, where you size up to do what you need to do, and then you size back down when you're done with that. Let's kind of go back to the admin view. There we go. Let's refresh this here. So we should be able to see that query as it's running in the back end. Here you go. You could see 1 minute 16 seconds. So as it's running, you can also click on it to see what's going on in your system as your users are running various queries. So you see there's step 1, creating that table, and you can see the various query plan and see what's going on. Oh, this is interesting. So partition scanned. As you can see, this is the micro partition. So while we're waiting for that, this is the micro partitions in total for 86,000 for all of those objects. We only need to scan 588. This is the third cache, percentage scan from cache. Because we're querying these objects for the first time, we don't have it in this computing power called power. But you see the benefits of reusing, common, like the marketing team would go to the marketing warehouse, so on and so forth, because then you would see kind of like there's some caching over here as well. As you see the various things. Let's see if we could see where the most expensive thing is. There we go. The most expensive node is this sort one. And if we click on it, we can go there. So if you ever wanted to troubleshoot and optimize, that's how you could do it, right? So if I want to see the next most expensive thing, it's that create table as. So read the documentation as to how to tune, your objects. All right, great. So that, oh, look at that. Wow. 1 minute, 21 seconds. I could update this. I guess, so I happen to be in AWS. So there have been some improvements lately to Snowflake. Let's see if I could see where my AWS, I think it's profile. Yeah, I know where it is in Classic, but I forget where it is in the Snowflake. But yeah, I happen to be on AWS West. Oh, here you go. Well, you could kind of see there that's US West too. But yeah, that was really fast. Okay, so now I'm going to size down. I'm going to switch my computing power to the junior one. So as you can see, now I'm back to the junior. And what's great is it looks like the power one automatically suspended, and the junior one also automatically suspended. So you see Snowflake's kind of like making it easier on you in terms of giving you, value, right? So what I want to do is I want to add a cluster key, and you can see that was really fast, right? Essentially, whenever I do a create table statement, I always order by, whatever, 1 to 4 columns, and then I also create a cluster key by those 1 to 4 columns as well. And that's good to kind of future-proof it, right? So as you can see, this comes in handy for your BI tools to run queries against these objects. And you see automatically clustering is on. So in the future, if more data comes in, Snowflake's brain is going to say, oh, maybe I should, tune these objects on their own. Those are completely online operations for fast performance. Okay. So let's run some more queries against our object. You see we created 58 million rows. We could see, let's kind of explore our data. As you can see, there are very wide. I'm just kind of scrolling right here. There's 120 columns right here. So there's a statistics pane. As you can see, the very many columns. You can do data discovery. You could do filtering right here because it's all kind of like in memory. Remove the filter, clicking that X. And then, so which managers had the most sales? So just showing you some sample queries, Robert Reyes, Brett Yates. So let's notice pruning, though not on the clustered key. Interesting. So some people say, well, what if you query, but it's not on the cluster key? So remember, our cluster key did not have manager in it, right? Now we already showed querying during the demo against the trader symbol and date, how fast that was. But notice we're querying against manager. Let's go to that took only 590 milliseconds. Let's see why. If we hit view query profile, perfect. Remember I said we wanted to see the third cache? We're seeing the percentage scan from cache is, 9% is already in the junior warehouse. And, it was very smart in that it only queried 9 of the 512 available micropartitions, because it essentially Snowflake's smart enough to say, as the data is in there, it does the min and max for the manager, and for every column that it kind of has like the min and max value. So it was able to prune and didn't have to table scan, right? There's a lot of value in that. And here are the actual 120 columns, right? If we scroll down, you can see all 120 columns. All right, so quick recap, what did we do? We ran create table statement as, and it took 1 minute and 21 seconds. And then, we only paid 60 seconds plus 21. So we only paid pretty much 81 seconds. And okay, so now we created that object. So now let's do changes to a clone, okay? So if we wanted to use this schema, and I want to drop a table if it exists, okay? And I want to create a transient table, the norm one clone. So this is changes to a Y table. I think that's what I should rename this. Show tables like this. So you can see we have the norm one and the clone of it. So coming back to my database, remember you're going to have your own user number unless you happen to be user 14. It's over here, sales the norm 1 and the clone of it. Now, as you can see, we have some item stock keeping units or serial key. I believe that's serial key, and the count of those objects, right? Sorted descending. So let's say we wanted to add new and improved to multiple attributes in a Y table. So I'm just going to grab one cigarette key, 376283, has about 402,000 records. That's what it looks like. So I want to run this. Well, we're using a small, so not an extra small, but we're using a small. And when updating this very wide 120 row table with new and improved, so on and so forth. So on a small, it took 6 seconds. So let me just do that. Small took 6 seconds. And we can verify that. It's going to say new and improved plus whatever our object is. So as you see, new and improved, right? Against those 309 rows. So what did I do, right? A lot of people are starting to use Snowflake for kind of like what's traditionally been more like an OLTP use case. Obviously, you're not going to get to like sub-second. But when you're getting into these big data realms where there's, 120 columns and lots of big data, Snowflake's pretty efficient at that, right? And pretty fast. Okay. So let's go into our transaction demo. So here's various states in our Y table. And let's say we want to have 15% margins, kind of like the Costco business model where here's the current price and our wholesale costs. And that doesn't seem right because if our current price is lower than our wholesale cost, we're selling it at a big loss actually. So what we're going to do is showcase a transaction. So we're going to do it interactively. Snowflake is the anti-transactions compliant. So we're deleting from this secret key for the state of Georgia, 105 rows were deleted. And we are like Costco and want 50% margin. So we're going to take the current price and make it a wholesale cost times 1.15. So it's current price is 15% more. And we're going to verify that the state of Georgia is not in our records anymore. And we're going to verify that we have the 15% margins now, which is kind of a nice way to do business because you're making 50% margins, kind of like a retail business or a Costco business. And no means no transaction. Okay. All right, so what does that show you? Well, there is a transaction because remember we did a begin transaction. So what do? We updated the records that says, Georgia is gone and we made it 15% margins here and we verified all that. So right now we are within a transaction, right? But if we roll back, it will basically undo everything since I started that transaction. So if I hit roll back, all right, so basically it undid everything. And actually this should show null now. All right, that shows null. And let's verify the rollback. So now the current price and the wholesale price, remember the current price should be lower than the wholesale cost, which is bad, really bad for business. Quick way to go bankrupt. And then the Georgia should return here because we basically roll back our transaction. Okay. And of course we could run 4 statements as a batch we're gonna basically do it for real now, but we're actually gonna commit it this time. So sometimes people want to like test what it would look like and then commit, and that's what we just did. We verified it. We are gonna run these as a batch. All right, so it committed, and so we could verify those commits. And as you see, the current price is more than the wholesale cost, and we can see that the record of Georgia is not there. All right, so that concludes our demo. Let's do a quick recap of what we did. We did pretty much this agenda. We showed Snowflake navigation, some keyboard shortcuts, data manipulation language on a 2.6 billion row table with no functions, cross database joins, zero copy clone time travel, ultra table swap with, created a wide table with 120 columns, switching instantly to a more powerful warehouse and then switching back down. We did updates and deletes to that wide table. We added a clustered key and we enabled auto clustering. And we looked at the query profile to see the performance to it, and we saw the 3 types of cache. Finally, we saw the transactions, rollback, and commit. So remember, everything is over here in this website. As you can see, Snowflake Labs, SF Guide, Financial Asset Management, and the contents to create that lab is over here. Thank you very much.